Welcome to the DIY Honda Garage channel. The DTC, or Diagnostic Trouble Code P2413, indicates a malfunction in the Exhaust Gas Recirculation (EGR) system for the Honda Civic model from 2022 onward. The EGR system helps reduce nitrogen oxide emissions and enhance fuel efficiency by recirculating a portion of the exhaust back into the intake manifold. In this case, the issue is detected when the EGR valve position sensor output is lower than a specified value, triggering the Powertrain Control Module (PCM) to store this error code. The EGR valve is typically located near the intake manifold, while the sensor monitors the valve's position and operation. The malfunction could be due to a variety of factors, including the valve itself, the related circuitry, or the PCM, necessitating comprehensive troubleshooting to pinpoint and rectify the underlying issue. It is crucial to follow the correct protocols in the service manual to ensure accurate diagnosis and repair of the vehicle's EGR system. DTC P2413 describes a malfunction in the EGR system caused by a faulty EGR valve position sensor. This sensor plays a critical role in monitoring the position of the EGR valve, which allows a specific amount of exhaust gas to re-enter the intake manifold. This process not only helps reduce harmful emissions, but is also vital for maintaining engine efficiency and performance. The EGR valve is typically located close to the engine's intake manifold. It is controlled by the PCM, which relies on data from the sensor to ensure that the correct amount of exhaust is recycled. If the voltage output from the sensor falls below a predetermined level, the PCM interprets this as a malfunction and triggers the DTC P2413. This sets the stage for subsequent troubleshooting steps to clear the malfunction and restore proper operation of the EGR system. Several factors can cause the DTC P2413 to trigger. A common cause is a faulty EGR valve or its position sensor. The EGR valve may be stuck, clogged, or electrically malfunctioning, which would impair its ability to open or close appropriately. Another possibility includes wiring or connector issues. Damaged insulation, corrosion, or loose connections in the wiring can lead to incorrect voltage signals being sent to the PCM. Additionally, the PCM itself may be malfunctioning, which could lead to incorrect interpretations of sensor data, triggering the DTC. Thorough inspection and testing of these components are essential to accurately identify the failure point. The symptoms associated with DTC P2413 can manifest in various ways. The most immediate indication is typically the illumination of the check engine light on the dashboard, alerting the driver to an issue with the vehicle's emission system. Additionally, the vehicle may experience poor performance, such as reduced power or rough idling, as the engine struggles with the irregular recycling of exhaust gases. Increased emissions are another critical symptom, as the faulty EGR system can lead to higher NOx, nitrogen oxide, emissions, which contravenes environmental regulations. Observing these symptoms can greatly aid technicians in focusing their diagnostics and troubleshooting efforts effectively. The first troubleshooting step involves confirming the voltage output of the EGR valve position sensor. Utilizing the Honda Diagnostic System, HDS, technicians should verify that the sensor is providing the correct voltage signal to the PCM. If it measures close to 0 volts, this indicates the sensor may be malfunctioning. If the voltage is higher than expected, but not conforming to specifications, further investigation may be warranted. Additionally, the technician should inspect the PCM for any related error codes, as they may provide clues about the nature of the fault. Any other DTCs related to the EGR system should also be addressed, as they could highlight interconnected issues. This initial step is crucial for isolating the problem before performing more in-depth diagnostic testing on the individual components. The second troubleshooting step is to conduct the HDS EGR test. This test is designed to assess the operational integrity of the EGR system. Technicians should hold the engine speed at 3,000 RPM without any load, such as being in park or neutral, until the radiator fan activates. Following this, the HDS should be utilized to run the EGR test. If the results are not satisfactory, indicating that the EGR system is not functioning correctly, it is essential to duplicate the failure under controlled conditions. This approach helps to confirm that the fault is consistent and allows for targeted repairs, whether it is an issue with the EGR valve, the sensor, or potentially even related wiring. In this third step, technicians should focus on inspecting the EGR valve's connectors and connections. It is essential to ensure that all connector pins are clean, properly seated, and free from corrosion, as this can significantly affect electrical communication. Technicians should perform continuity tests on the wiring to verify that there are no breaks or short circuits. Utilizing a multimeter, it's vital to measure the voltage readings at the EGR valve while the engine is on to confirm that the correct voltage levels are being supplied. Any discrepancies in these readings compared to manufacturer specifications would indicate a wiring issue or a fault in the EGR system components, leading to further troubleshooting of either the valve or related circuitry. Step 4 entails inspecting the EGR passage and EGR port for signs of blockage or fouling. Over time, carbon buildup can occur in the passages, restricting the flow of exhaust gases and affecting the EGR system's performance. To carry out this inspection, technicians should remove the EGR valve and associated components to gain access to the passages. A thorough cleaning using a throttle plate cleaner can help remove any carbon deposits or debris. After the cleaning process, it is vital to run the HDS EGR test again to confirm that the functionality has been restored and to ensure that there are no remaining blockages obstructing the system. This step is critical as it helps eliminate dust and blockage as potential issues underlying the DTC P2413. During the fifth troubleshooting step, technicians will examine the wiring leading to the PCM, or Powertrain Control Module. Before disconnecting the PCM connector, it is essential to jump the SCS Service Check Connector line with the HDS to ensure an accurate reset and prevent any disruption in the diagnostic data. Once disconnected, the technician should perform thorough checks for open circuits and ensure that the wire resistance levels adhere to manufacturer specifications, typically less than 1 ohm for open wire inspections. Any wiring issues found during this step can be a major contributor to the problems indicated by DTC P2413. If the wiring checks out and the system still exhibits faults, it may indicate a malfunction directly within the PCM, prompting a more detailed inspection of the module itself. The sixth troubleshooting step focuses on testing the functional capabilities of the EGR valve using a manual jumper method. First, ensure that the EGR valve's 5P connector is disconnected to prevent any electrical feedback. Then, using a jumper wire, connect terminal number 5 of the EGR valve connector to the positive terminal of a 12-volt battery to energize the valve. Start the engine and let it idle. Then connect terminal number 1 to the battery's negative terminal to facilitate EGR operation. Technicians should observe the engine's behavior during this test. If the engine stalls or runs roughly, it tends to indicate that the EGR valve is functioning correctly. If not, there's likely an internal failure in the EGR valve that necessitates replacement. After completing all necessary repairs, the final step involves verifying that the repairs were successful. Begin by using the HDS to clear the stored DTC P2413 from the system memory. After this, a test drive of the vehicle is essential to monitor its performance. During the drive, observe any unusual engine behavior and check if the check engine light remains off. It's also helpful to run another HDS EGR test post-repair to confirm that all system functions are within specification. Finally, continuous monitoring of the vehicle's emissions and overall performance will ensure that the repair has successfully resolved the issues associated with DTC P2413. Preventive maintenance is crucial in avoiding issues that lead to DTC P2413. Regularly inspecting the EGR system can help catch potential failures before they escalate. This includes cleaning the EGR ports and passages to prevent carbon buildup, which can lead to clogs and malfunctions. Additionally, keeping an eye on the health of the EGR valve and its position sensor by tracking any changes in engine performance can also aid in early diagnosis of potential issues. Timely replacement of faulty components can significantly improve the longevity of the system and ensure optimal vehicle emissions performance. Implementing these preventive measures will not only provide peace of mind, but also enhance the vehicle's operational efficiency. In conclusion, understanding DTC P2413 and its implications on the Honda Civic's EGR system is essential for maintaining optimal vehicle performance and compliance with emissions regulations. The EGR system plays a vital role in reducing nitrogen oxide emissions and maintaining fuel efficiency. Regular diagnostics and timely interventions are crucial to prevent any long-term damage and ensure that the vehicle operates smoothly. By following the troubleshooting steps outlined, technicians can accurately identify and fix the problem areas. Ultimately, proactive maintenance and a thorough understanding of the components involved will contribute to a more reliable and efficient vehicle. Please like and subscribe to the channel. See you next time.